Today we are going to focus on arithmetic and geometric convergence or divergence. I am planning to upload a lot of videos in the future, lots of practice problems. Please hit that subscription button. It will be very helpful, and I understand what you need. And click on the bell icon to be notified anytime I upload new videos. Let's start with some reviews. At the very top left hand side we have two sequences, the top one and the bottom one. The top is the arithmetic sequence, an infinite arithmetic sequence, since it begins with a number and ends with dot dot dot, continues into infinity. And at the bottom we have the geometric sequence. It's a finite geometric sequence, meaning it has the beginning and the end. It starts with 2 and ends with 64. On the right side cross, we have the series, adding the terms together, series. And that one is also, the top one is the infinite series, infinite arithmetic series, and the bottom one is a finite geometric series. So like sequences, series could be finite or infinite, geometric or arithmetic. Some of the formulas we need is mean. Sometimes you're asked for mean arithmetic. So m equals the average of two terms, a sub y plus a sub x divided by 2. For instance, if we want to get the mean of a sub 1, a sub 3, top sequence, arithmetic sequence. So we have m equals 7 plus 13 divided by 2 equals 20 divided by 2 equals 10. So it's always the middle number. The other one is a arithmetic partial sum. How do we get that? So S sub n for arithmetic sequences equals a sub 1 plus a sub n divided by 2 times n, the number of terms involved. Let's say if you want to get the first 4 terms, starting with 7 ending with 16. So a sub 4, a sub 4, a sub 1, 7, sub 4, 16 divided by 2 times 4. Okay, sub 4 equals, the top we have 23 divided by 2 times 4. We can factor out 2, we get here 2, and then S sub 4 equals 46. So it's 46 is S sub 4. So let's see, we have a limited number for this. We can just add them all. We have the list. 7 plus 10, 17 plus 13, 30 plus 16, 46. Now, geometric mean. Geometric mean is the square root of the product of two intended terms. So example, for instance, you want to get the mean of a sub 1 and a sub 5 in the bottom geometric sequence. So a sub 1, the square root of a sub 1, 2 times 32 equals the square root of 64 equals 8. Finite partial sum, geometric finite partial sum, S sub n equals a sub 1 times 1 is r to the n divided by 1 minus r. And here, if we want to get this partial sum for the first two terms, first four terms, let's see, we're starting with 2n, ending with 16. So we can have s sub 4 equals is a sub 1 times 1 minus r is 2 here to the 4 time divided by 1 minus 2. Then s sub 4 equals, we have at the top 2 times 1 and minus 16 divided by minus 1 equals 2 times minus 15 minus 30 divided by minus 1 equals 30. We also, for geometric sequence, geometry, we have also the infinite sum. Some may exist, some in geometric series. And that is, for infinite geometric series, we have s sub n equals a sub 1 divided by 1 minus r with one condition. Absolute value of r must be less than 1. Sigma notation is just a shorthand. It's a compact form to represent series. It's a Greek capital letter, where we put the last value of n, the first value of n, and here is a sub n, or the formula for the terms. Let's say we want to get works a little bit on the sigma notation or summation notation for 2 plus 4 plus 6 plus 8 plus 10 plus dot 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 infinite series. Okay, so here we have to find the general formula. So let's see, we have here the 2 as a d is an arithmetic sequence, and the starting a sub 1 is 2. So a sub n equals a sub 1, if you want to find the general formula, plus n minus 1 times d. Let's plug in what we have. A sub n equals a sub 1, 2 plus n minus 1 times 2, right? 2. Then a sub n equals 2 plus 2n minus 2. We can add the like terms. So we have here a sub n equals 2n. Okay, so we have everything now to write down the sigma notation or summation notation representing the series we have here. So again, we have sigma. So we have here infinite. It starts with n1, and then the formula for our terms is 2n. 2n. Sequence, convergence, or divergence. All right, so a sequence will be converging if it's equal to a specific value. It means that if the limit of that a sub n, as n approaches infinity equals the value, specific value like L, then the sequence sequence converges. If it's not equals anything else like infinity, minus, plus, and so on, then the sequence diverges. If equals infinity, diverges. So what do we have here? We have to take a limit of the sequence. Limit of a sub n to n plus 1 as n approaches infinity. Let's substitute. We have equals 2 times infinity plus 1. 2 times a large number plus 1. 3 is a large number, is infinity. So it's not equal to a specific value. So the sequence diverges. The sequence diverges. The next one, we have a sub n equals 1 over 2 to the n. The limit of that, the limit of a sub n as n approaches infinity, here's a sub n, we have 2 over, so equals 1 over infinity, a constant, divided by a very, very large number equals 0. So it's equal to specific value. Here, the sequence converges. Converges. Sequence converges. Here we have a sub n. A sub n equals 4n divided by 2n minus n. This a sub n, before we can take the limit, we need some algebraic operation. So let's see. Multiply the numerator and the denominator by 1 over n times. So meaning that 2 or 4n divided by 2 minus n times 1 over n, 1 over n equals 4 divided by 2 over n minus 1. So what? Now we can take the limit. The limit of 4n divided by 2n minus n as n approaches infinity equals the limit of 4 divided by 2 over n minus 1 as n approaches infinity. We know the limit of a constant over a large number equals to 0. So we end up having minus 4. So the limit of the sequence equals a specific value. So we know the sequence will converges. There is convergence or divergence. To know whether a series diverges or converges, we can take the limit of the partial sum. In order to do the limit of the partial sum, we need to know what type of sequence we have and whether or not the sum exists. Then we take the limit of that. So the one method is to take the limit of the partial sum. So what type of sequence we have? Let's say limit of partial sum. Limit of partial sum. What type of sequence we have? Let's plug in some numbers. we have a sub n equals 2 times 1 plus 3 equals 5. We start the a sub 1 is 5. Again, a sub 2 equals 2 times 2 plus 3 equals 4 plus 7 plus 3, 7. And a sub 3 equals 2 times 3 plus 3 equals 9. So we are going from 5 to 7, 7. So we are adding 2. So d equals is an arithmetic sequence with d equals 2. So and a sub 1 equals 5. We just write it down. A sub 1 equals 5 in arithmetic sequence and d equals 2. So we know the C type of sequence. So we have to see what the partial sum is. Partial sum is sub n equals a sub 1 plus a sub n divided by 2 times n. So, and then from here, s sub n equals, what is the first number? 5. First term, 5 plus, and the a sub n is just generally 2n plus 3 divided by 2 times n. S sub n equals, let's do some work on it. 5 plus 3, 8. So 8 plus 2n divided by 2 times n. Let's factor 2 from the numerator and the denominator. So we get equals 4 plus n times n. So we can take the limit of this. The limit of a sub n as n approaches infinity equals the limit of 4 plus n, 4 plus n, 4 plus n, 4 plus n times n equals, as n approaches infinity, equals 4 plus infinity times infinity. What is it? So of course it's infinity. So the limit of the sequence is, limit of the partial sum is not equal to a specific value. Is not equal to a specific value, and the series will diverge. So the series is diverging. Series is diverging. Series is diverging. Another way to find whether or not a series is converging or diverging is using the divergence test. So we have to mark the second time. Using is the divergence test. It's a divergence test. So we take the limit of a sub n as n approaches infinity. If it's not equal to 0, then the series diverges. Series diverges. If equal to 0, may or may not, we do something to work on it, may or may not diverge.
So for this one, for what we have here, limit of 2n plus 1. So we have the sequence, the limit of 2n plus 1 as n approaches infinity equals the limit equals I'm sorry, let's see, equals 2 times infinity plus 1. This equals infinity. So the sequence of the sequence diverging and is not equal to 0, is not equal to 0, and the series diverge. Series diverges. This is not equal to 0. Let's do some other work on some other examples. We have here the series. The series of so the series we have here started with n equals 4n plus 3 divided by 1 over 1 plus n. A sub n is, so a sub n needs to be, we need to do some operation, then take the limit of the sequence. So let's multiply the top and the bottom of the a sub n by 1 over n times 1 over n times 1 over n. So we have, then we get a sub n equals 4 plus 3 over n divided by 1 over n plus 1. So the limit of a sub n as n approaches infinity equals the limit of 4 plus 3 over n divided by 1 over n plus 1 as n approaches infinity equals 4. Right? So since this is 0, and so it's the sequence is the limit of the sequence equals a specific value and is not 0. Still the series, therefore the series diverges. Remember that, diverges. That's what the divergence test says. If it's not equal to 0, the series diverge. The next one, we have infinite series of n 1 over n. It's an harmonic specific type of series called harmonic series. So equals 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus ... into infinity. So what is the limit of the a sub n? A sub n as n approaches infinity equals the limit of what? 1 over n equals 1 over infinity equals 0. So it's equal to 0. May or may not be diverging. Is equal to 0. So the sequence is, we know is the sequence, the limit of the sequence is converging, but the series, what happens to series? Look at the top. We have something very small amount, gradually getting smaller and smaller, but it's adding something. So the series is diverging. The series is diverging. Sequence is convergence, but the series diverges. Series. The next one is what we have as the infinite series of 1 over 3 to the n. So equals 1 over 3 plus 1 over 27 plus 1 over 81 plus dot dot dot. So this is an example of a geometric series. Geometric series with r equals 1 over 3, and the first is of 1 equals 1 over 3. Now let's take the limit. The limit of 1 over 3 to the n as n approaches infinity equals 1 over infinity equals 0. So the sequence is converging. But how about the series? So we know the r is less than absolute value of r is a geometric sequence less than 1. So we can get there is a sum for it. The sum exists in the series, and that is s equals s of 1 over 3 divided by 1 minus r over 3. The result is 1 over 2. See that, huh? Not 2 over 2. 1 minus 2 over 2. 2 over 3 and 1 over 3 divided by 2 over 3 is equals to 1 over 3 times the reciprocal of 2 over 3, which is 3 over 2, and equals 1 over. So the sum exists in this infinite series. What does it mean? Meaning that the sequence is converging, also the series divergence. So the series convergence. I'm sorry, series converges. Series converges.